Hello and welcome back to another video. This problem in triangle RST, we're told that point W, which is not shown, lies on the line segment RT. We're asked to find the cosine of angle RSW minus the sine of angle WST. So if we just pick a point W, right, it doesn't have to be anything in particular because we don't know where W is. If we draw this line right here, WS, then angle RSW is going to be this angle right here, and angle WST is going to be this angle right here. So let's just look at the angles first. Angle RSW plus angle WST, so this angle plus this angle is equal to angle RST. RST is 90 degrees. We're told that it's a right angle based off of our givens. So angle RSW plus angle WST is equal to 90 degrees. And if we're told that angle RSW is equal to 90 degrees minus angle WST, right? We find that just by subtracting angle WST from both sides. Then this expression is equal to cosine of 90 minus angle WST minus the sine of angle WST. What is this equal to? Well, the cosine of 90 minus an angle is equal to the sine of that angle. So this is equal to the sine of angle WST. I'll show why that's the case in a second. This is minus sine of angle WST. Sine of WST minus the sine of WST is 0 because you're just taking something and you're subtracting itself. Why is the cosine of 90 minus an angle equal to its sine? Well, if we have just any right triangle, right, where we have A, B, and C, and we have a right angle here, right? And let's just say we have side lengths X, Y, and Z. In this triangle, angle A plus angle B plus angle C is equal to 180 degrees. Because the interior angles of a triangle add to 180 degrees. If angle A is 90 degrees, plus B plus C, equal to 180. When we subtract 90, these cancel. We get angle B plus angle C is equal to 180 minus 90 is equal to 90 degrees. So these two angles add up to 90 degrees in the same way that 90 minus angle WST and angle WST add up to 90 degrees, right? 90 minus angle WST plus angle WST. Well, this minus version plus the positive version cancels out and you're just left with 90. And in this case, we're looking for the cosine of one and the sine of the other. So let's look for the sine of B is going to be the opposite side, which is X, divided by the hypotenuse, which is Z. And we're looking for the cosine of C. Sine of B, cosine of C. So the cosine is the adjacent side, which is X, over the hypotenuse, which is Z. So we have X minus C minus X minus C, just like here, is going to be 0. So 0 is your final answer. As always, thank you for liking and subscribing, and I'll see you in the next video.